Day 19, Advanced Algebra 2, video part 2. We need to look at another example for squaring a binomial. This time let's consider the binomial x minus 7 squared. Remember, the process when squaring a binomial requires us to FOIL the binomial multiplied by itself. So I'm going to rewrite the problem as x minus 7 times x minus 7, and then FOIL for my results. My first product is x squared. My second product for the outside terms is a negative 7x. My third product is from the inside terms, which is a negative 7x as well. And my last product is a product of the last terms, which produces a positive 49. Negative 7 times negative 7 is positive 49. When we combine like terms, we have x squared, which cannot combine with anything. The two 7x's can combine to make a negative 14x, and our last term is 49. Does this follow the pattern that we decided in our first video? Well, what we're looking for is the first number squared. The second number from our binomial must also be squared with a positive sign. And the middle term must be 2 times the product of our first and second term. Let's check it out. Was our first number squared? Yes. Was our second number from the binomial squared and placed at the end? Yes. And it has our positive sign. Lastly, is this middle term equal to 2 times the product of the two terms of the binomial? 2 times x times negative 7 does equal negative 14x. So again, we have a result that matches the pattern of a squared binomial. Now I'm going to work an example that increases the difficulty just a little bit. We'll mark this one down as number 3. Let's consider what happens when we multiply 5x minus 4 times itself, or in other words, this binomial squared. Remember, we must first rewrite the problem. 5x minus 4 times 5x minus 4, and then FOIL the result. For my first two calculations, I'm left with 25x squared. For my outside calculations, 5x times negative 4 is negative 20x. My inside calculations, negative 4 times 5x is another negative 20x. And for my last calculations, I have 4 times 4, which is a positive 16. When we combine like terms, we're left with 25x squared minus 40x, and finally plus 16. Is our first number from the binomial squared in the result? Yes. Is our second number from the binomial squared in the result? Yes. Do we have a positive sign at the end? So far, so good. Lastly, we need to verify that negative 40x is indeed equal to 2 times our first piece of the binomial times the second piece of the binomial. Remember, it should be 2 times a times b. This is the form from the original video, and we're going to check that math here. 2 times 5 is 10. 10 times negative 4 is negative 40. That takes care of my coefficients. X is the only piece that's left and has nothing to combine with, so we recognize that that center term should have been negative 40x. That's exactly what we have here. So our solution here in this box does represent the product or the square of a binomial. I'm going to write down problem number 4, and I'd like for you to try that one on your own. Then check with me, check with the rest of the video to see if your answers match. Fourth example that we're going to look at is 3x plus 5y squared. Please pause the video now, complete the math, and verify your work in just a couple seconds. Your result should be 9x squared plus 30xy plus 25x. I'm sorry, I wrote the wrong variable here. 25y squared. 25y squared, since our original problem had a y in the second position of the variable. When double checking, you'll see that this follows the product of two binomials, or the square binomial. So the first term gets squared, the second term from our binomial is squared, and the middle term in our result is 2 times the product of our original pieces of the binomial. We're going to continue with one more video.